Good afternoon for all of you. I hope you are fine, you and your family. Please stay at home and be careful. With you, Mr. Mostafa Ibrahim from Tabarak Private School.
Assalamu alaikum wa rahmatullahi wa barakatuh. Today, inshallah, we will complete what we start in part 1 and part 2. This video contains two parts. Part 1 about naming of some alcohols, and number 2 types of isomerism. Firstly, about naming alcohols. But if you see later, we will talk about alcohols, aldehydes, and ketones. So naming of aldehydes, ketones, and carboxylic acid will be explained on the videos of aldehydes, ketones, and carboxylic acids. So now we will finish naming of alcohols. Start from the first compound. If you count how many carbon atoms, 1, 2, 3, 4. Numbering from right or left? Yes, right. Why? Because it is nearest to the OH group. So 1, 2, 3, 4. So the name butane. And you have to write the position of OH at carbon atom number 2. So butane 2-ol. Or you can write 2-butanol. Any one of them is correct. Number 2. Count the number of carbon atoms. Don't start from OH. Start from this carbon. So how many carbon atoms? 1, 2, 3. So now I have 3 carbon atoms. So the name will be what? Propane. Propane. And you have to mention the position of OH at carbon atom number 1. So propane 1-ol or 1-propanol. Number 3. How many carbon atoms is the longest chain? Yes, 4 carbon atoms. 1, 2, 3, 4. Numbering from left, not from right. 1, 2, 3, 4. So OH at carbon atom number 2, and you have a branch at carbon atom number 3, methyl. So the name will be 3-methyl butane 2-ol. Number 4. Count the number of carbon atoms. You have 4 carbon atoms. You start numbering from left. You have at carbon atom number 2 OH and also branch CH3. So you have to write the branch firstly 2-methyl, then 2-butanol. The last one on the right down, you have to count firstly the longest chain. How many carbon atoms? Yes, 6 carbon atoms. When you start, you have to start from left or right? From right, nearest, the nearest, or which give OH the lowest number. Don't look to the branch, look to OH group. So I start from right. So now you have branches at carbon atom number 3 and 5. So the name will be 3 and 5 dimethyl 1-hexanol, or you can write 3 and 5 dimethyl hexane 1-ol. After that, the second part about isomerism. Isomerism, we have two general types: structural isomerism and stereoisomerism. Firstly, what is isomerism? Isomerism, they have the same compounds, different compounds. They have the same molecular formula but different structural formula. This is structural isomerism. But in stereoisomerism, the same molecular and structural but different arrangement in space. In structural isomerism, we will talk in the next slides about 3 types: chain and positional isomerism and functional group isomerism. In stereoisomerism, we have geometric, or we call it cis and trans isomerism, and we have optical isomerism. So let's start with the first one, chain isomerism. Chain isomerism, usually it is present with alkanes, but we can make it in any other family. How in a chain isomerism? A chain isomerism, we only change the number of carbon atoms in the longest chain. And if you check hexane, how many carbon atoms in a straight chain? 6 carbon atoms, so the name hexane. So if I make one branch, so the longest chain now down, you will find the longest chain 5 carbon atoms, and you have a branch at carbon atom number 3, so the name not hexane, it will be 3-methyl pentane. And if you make 2 branches at carbon atom number 2 and 3, so now the longest chain not 6 carbon atoms, the longest chain 4 carbon atoms, 2 and 3 dimethyl butane, but all of them hexane or 3-methyl pentane or 2 and 3 dimethyl butane, all of them the same molecular formula C6H14 but different structure. The second type of structural isomerism, positional isomerism. It is very easy. Only we change the position of the branch or the functional group. For example, let's compare number 1 and 2. What is the difference between them? Both contains 5 carbon atoms. 1, 2, 3, 4, 5. But what is the difference? The position of OH at number 1 at carbon atom number 1. So the name will be 1-pentanol. But in number 2, the position of OH at carbon atom number 2. So the name will be 2-pentanol. Let's compare number 3 and 4. What is the difference between them? Both have 4 carbon atoms. But what is the difference? The position of double bond. That's why it is called the positional isomerism. So in number 3, the double bond after carbon atom number 2. But in number 4, the double bond after carbon atom number 1. So number 3 is called but2-ene and number 4 but1-ene. The last 2 compounds in this page, see how many carbon atoms in the longest chain. If you count on the left or on the right, you will find 5 carbon atoms. All single bonds, so one of alkanes, so the name will be pentane. So what is the difference? Cl, the position of Cl on the left at carbon atom number 1, but on the right at carbon atom number 2. So the name 1-chloropentane and the second one 2-chloropentane. The third type of structural isomerism, functional group isomerism. In functional group isomerism, the family totally changed, the compound, its name totally changed. Let's compare the first 2 compounds. On the left you have C3H6O, also on the right. But what is the difference? On the left you have one of aldehydes, CHO, propanol, but on the right, propanone. One aldehyde, one ketone. You change the functional group. One is aldehyde and one is ketone. Number 2, on the left you have propanoic acid, carboxylic acid, but on the right you have CH3COO-CH3. This is one of esters, will be taken on chapter 7 in carboxylic acid, methyl ethanoate. The last 2 examples, you have ethanol and one of ethers, dimethyl ether. But if you compare how many carbon atoms? C2H6O, also on the right C2H6O. The difference only in the functional group. On the left OH, on the right only O. Alcohols and ethers. Now we will move to the geometric isomerism. Geometric isomerism, you have two types, cis and trans. They have the same molecular and structural isomerism. The difference in arrangement in space. If you arrange the groups on the same side of the double bond, this is called cis. If you arrange them on opposite sides, it is called trans. See number 1, cis 2-butene. Why? CH3, two groups on the same side, but on the right, on different sides or opposite sides. So same side, cis, different sides, trans. Down, Cl atoms. On the left, they are arranged on opposite sides. So the name will be trans 1 and 2 dichloroethene. But on the right, Cl atoms, it doesn't matter you arrange them on the same side, down or up, but on the same side, so its name will be cis 1 and 2 dichloroethene. Now the last type, it is called optical isomerism. Optical isomerism, it occurs when I have chiral center. What is meant by chiral center? It is a carbon atom bonded with 4 different groups. See the compound, down, carbon. It is bonded, you know that carbon, it forms 4 bonds. See the 4 groups, all of them different. H, OH, CH3, CO2H. So if I have 4 different groups, so this carbon is called chiral carbon. What's meant by chiral carbon? It is carbon atom bonded with 4 different groups. So this is the last type about optical isomerism. Thank you. I hope you understand this lesson. Please be careful and stay at home. Don't forget, homework will be uploaded on Moodle. Thank you for listening. Goodbye.
I hope you are enjoy the listening and you understand the topic we explained today. We appreciate the efforts of Mr. Yunus Rahbi, the chairman of Tabarak Private Schools Group, and don't forget your homework is uploaded on Moodle on Tabarak Private School site. Thank you and goodbye.